if you know the initial point and the terminal point, in order to write the vector in component form, you just need to talk about where it goes. So from -2 to 7, that has to increase in the x direction by 9. You're doing, basically it's x2 minus x1. So the x component will be 7 minus -2, which is 9. And then the y component will be 1 minus 3, which is -2. There's component form. You could do it as x2 minus x1 and y2 minus y1. When you're finding the magnitude, you're just finding the length. So you're really just doing distance formula. So this will be for A, do the square root. 7 squared plus 12 squared. So 49 plus 144. Square root of 193. That's the magnitude of V. For B, it's the same thing. Square root 3 squared plus -6 squared. That's 9 plus 36. That's 45. You could simplify that to 3 square root 5. There's your magnitude. When you're doing operations with vectors, u plus v means you add the x components and you add the y components separately. So u plus v, we're adding 3 and -7 to get -4. Then you add 9 and 5 and you get 14. So there's u plus v. For u minus v, it's pretty much the same thing, but with subtraction. 3 minus -7. So that's 10. And 9 minus 5, 4. Three u plus 11v. So you have to first multiply everything on u by times 3. So we're really going to treat that as 27. Or sorry, 9 comma 27 plus 11v. So that would be -77, 55. And those are the numbers that we're adding together. So 9 minus 77 is -68. And then 27 plus 55, 82. And then for the last one over here, -2u minus 4v. -2 times u would be -6. Comma -18. And we are subtracting 4v, so that will be minus -28, 20. You could have included the -4 there and said it was adding and changing those signs. That would work out the exact same. So that would be 22, comma, -38 as our vector. Find a unit vector with this direction that's the same as 3, -4. So all that means is, since magnitudes are direction and magnitude, we just have to divide by magnitude. So it only has direction. So we're going to divide by the magnitude. So if this is 3, 4, that means the magnitude is 3 squared plus -4 squared. 9 and 16 is 25, so that's square root of 25, which is 5. If the magnitude is 5 and we're dividing that off our vector that has the same direction, would go 3/5 and -4/5. Just divide each component by 5. So now we've got one where we have a given vector. We want that direction. We do not want that magnitude, so we have to divide by the magnitude. And we will change its magnitude so it's got a length of 12. So we just have to multiply back our new magnitude. So first change u into a unit vector, so we need to know the magnitude of u, which is 6 squared plus 9 squared, 36 and 81. So square root of 117. So 117, we can break that down just a little. It's 3 times 39. 39 is 3 times 13. So there is a pair of 3's. So let's change that to 3 root 13. So that's the magnitude of u, which means u as a unit vector would be 6 divided by 3 rad 13, comma 9 divided by 3 rad 13. And of course that reduces. The 3 makes that a 2, and the 3 makes that a 3. Now we are changing the magnitude. This currently has a magnitude of 1. We want it to have a magnitude of 12. The unit vector, so the magnitude is 1. To give it a magnitude of 12, you just multiply it by 12. So that's 12 times 2, 24 over the square root of 13. And then 12 times 3, that's 36 over the square root of 13. And I'm okay with leaving the square roots in the denominator. So we'll do some dot products. U dot V means we're going to multiply the x component times the x component and the y component times the y component. And you add those answers together. So U dot V means 2 times -3, that's -6. -7 times 5 is -35. Add that together and you get -41. V dot U, it's the same thing, but you're supposed to multiply the other direction. So it would be -3 times 2 is -6. 5 times -7, still -35. So it will be the same thing. U dot V times W. We already did U dot V, so let's save some time. That's just -41. Times W, which is 4, 8. You have to distribute the -41 into the vector now. So it's -41 times 4. And -41 times 8. There you go. And then for our last one here, W dot W, we're doing 4 times 4, 16, plus 8 times 8, 64. So that's 80. And just a reminder that that is equal to whatever the magnitude of W is squared. One of those little theorems that we had along the way. So to find the angle between vectors, we'll use this formula. Cosine of the angle equals U dot V divided by the length multiplied together. So dot product is pretty easy to figure out. So that will go up top. The harder part is finding the magnitude of each. So the length of this vector would be square root 3 squared plus 0 squared. So that's square root of 9, which is 3. And then the length of vector V is the square root of 16, 4 squared, plus 25, which is 5 squared, square root of 41. And the dot product for the numerator would be x component times x component, so that's negative 12, plus y component times y component, which is 0, over the lengths multiplied together, so 3 times square root of 41. So that's just negative 12 in the numerator over 3 square root of 41. You could simplify that to be negative 4 over square root of 41. And we need what angle has a cosine value equal to that. So we're going to do shift cosine, arc cosine. Negative 4 over square root of 41. 128.66 degrees. That's the angle between the vectors.